Now it's time to pick up the pace on the chapter. We spent a lot of videos looking at the first two lessons in the chapter, just kind of setting up the rest of it. Well, we're going from 5.1 and 5.2, that was the derivatives and integrals of natural logs, to 5.4, where we're going to get to the best function in all of calculus. But first, let me just give you a quick breakdown. We're going to derive this. You remember that the natural log of e to the x is just x. They are inverses of each other. What would happen if I took the derivative of both sides? Well, that's really quite easy on the right-hand side. That looks like it's just going to be 1. On the left-hand side, I would take the reciprocal of e to the x times the derivative of e to the x, which leaves us to one conclusion. I don't know what the derivative of e to the x is. But we just figured it out. If I multiply both sides by that, oh my gosh, we just proved that the derivative of e to the x is itself. That is the best function in all of calculus. As a matter of fact, if the derivative of e to the x is e to the x, guess what the integral of e to the x would be? I sure hope you're thinking along the same lines as me. First, we'll take on some examples of derivatives. By the way, don't forget use substitution. If you have another function inside of this exponential, make sure you use that exponential rule, but then multiply by the derivative of u. This is really important to know, but it should be really easy to know. So if you look at these as you go, the derivative of this first one, oh my gosh, is the exact same thing times, don't forget, the derivative of cotangent. Down here for example 2, what special rule would we use? Yes, that's right. It's the product rule. And once you've taken the product rule, the derivative of the first times the second, plus the derivative of the second times the first, what can you simplify? Nothing. You can make it look a little prettier, but there's nothing to simplify there. As we look at example 3, we're going to have to use the quotient rule. And that's okay. Use the quotient rule. God, that's ugly. That's absolutely terrible. But we use the quotient rule, and by the time you clean it up, it still looks ugly. Yeah, there's really no simplifying this monstrosity. I wish there was. Nothing we can do. Let's look at some integral examples. Well, in the first two examples, these are going to be pretty straightforward. In fact, if you see something that's exponential in an integral sign, you will almost always, if it is exclusively there, look at the power is going to be u. If you have just one exponential, the power is what u is going to be equal to. Let me write this out. So you'll see that it's going to work out really well. Whether we have any extra numbers around here or not, we can solve for u and clean up this problem. Same thing here. It appears to have two totally different functions, and then you realize the denominator is actually the derivative of that power. And then when we rewrite, it simplifies quite a bit. You see, just like a good fairy tale, it all works out with a happy ending. We enjoyed that. Problem number 3 is a little different though. In the top two, we had an exponential, so we suspected that that power was going to be equal to u. On that bottom example, we noticed that we have two different exponentials, one in the numerator and one in the denominator. So now it's time to get creative again. Think about what we could use in this chapter, and think about what would be a good value for u. If you suspected that u was going to be the entire denominator, you were correct. Pun intended. Yes, so you take that, you do a little cleanup here, and sure enough, it's going to look a lot nicer. In fact, I think we've got negative du over u, which reminds me of something that my friends like to call the little logarithm. So once again, it all works out well. Don't forget your log rules. If you have an integral of an exponential, please remember to look at that power as the value of u for u substitution. But if you have more than one exponential, get creative. Remember, if u doesn't work the first time, try it again.